Hello everyone. Today we will talk about Hangfire architecture. Hangfire's architecture is a robust, decompiled system designed to handle the complexities of background job management with high reliability. It follows a distributed client-server storage model, ensuring that long-running and scheduled tasks don't block your application or your main thread. So the first component is client, which is also known as job creation. The client is a piece of code within your application that initiates a background job. When you call a Hangfire method such as background job.enqueue, background job.schedule, or recurring job.add or update. So we have three steps: capture and serialization. It captures the method's expression and its arguments. Then serialize this information, usually into JSON format. Second, we have stage definition. It determines the initial state of job. And third, we have push to storage. It pushes the serialized metadata into the job storage. The second component of architecture is job storage, which is also known as persistent layer. This is the source of truth and the most critical component of reliability. Unlike in-memory queues that lose data during crash, Hangfire uses persistent storage such as SQL Server, Redis Cache, or PostgreSQL. It follows three steps. First is reliability. Once a job is in storage, it is safe. If your web server restarts or power goes out, the job remains in a database until a server successfully processes it. Second, we have centralized queue. Storage acts as a centralized hub. One or more clients can push jobs in, and one or more servers can pull jobs out. Third, we have transactionality. Hangfire uses database transactions or atomic operations to ensure that job is never lost during hands-off between storage and the server. Third component of Hangfire architecture is Hangfire server, which is also known as job execution. The server is a set of background threads that sits inside a process, which could be the same web application as a client or separate Windows service or console application. It follows four steps. So the first one is polling and fetching. The server continuously polls the storage for jobs that are ready to run. Second, we have execution. When it finds a job, it deserializes the method calls and executes it using its own worker thread. Third is state updates. After execution, the server updates the job state in the storage to success. If job fails, server moves it to the failed state and automatically schedules a retrieve based on predefined backup policy. Fourth, we have scalability. You can spin up multiple server instances on different machines. They will all point to the same storage and automatically distribute the workload. Fourth and main component of our architecture is a dashboard. Hangfire includes a built-in web-based UI. This is not just a viewer, it is a management console. So we have further two components in a dashboard. So first one, we have visibility. You can see real-time graphs of job throughput, looks at the history of every job and see the exact exception details if job fails. Second, we have control. You can manually trigger recurring jobs, delete pending tasks, or requeue failed jobs with a single click. If you enjoy this kind of content, don't forget to like, share, subscribe and comment.